Have you ever daydreamed about travelling through time? Perhaps fast forwarding the centuries and seeing the distant future? Well, time travel is possible, and what's more, it's already been done. Meet Sergei Krikalev, the greatest time traveller in human history. This Russian cosmonaut holds the record for the most amount of time spent orbiting our planet, a total of 803 days, 9 hours and 39 minutes. During this stay in space, he time travelled into his own future by 0.02 seconds. Travelling at 17,500 miles an hour, he experienced an effect known as time dilation. And one day the same effect might make significant time travel to the future commonplace. To see why moving faster through space affects passage of time, we need to go back to the 1880s, when two American scientists, Albert Michelson and Edward Morley, were trying to measure the effect of the Earth's movement around the Sun on the speed of light. When a beam of light was moving in the same direction as the Earth, they expected the light to travel faster. And when the Earth was moving in the opposite direction, they expected it to go slower. But they found something very curious. The speed of light remained the same no matter what the Earth was doing. 2 decades later, Albert Einstein was thinking about the consequences of that never-changing speed of light. And it was his conclusions, formulated in the theory of special relativity, that opened the door into the world of time travel. Imagine a man named Jack standing in the middle of a train carriage travelling at a steady speed. Jack's bored and starts bouncing a ball up and down. What would Jill, standing on the platform, see through the window as the train whistles through? Well, between Jack dropping the ball and catching it again, Jill will have seen him move slightly further down the track, resulting in her seeing the ball follow a triangular path. This means Jill sees the ball travel further than Jack does within the same time period. And because speed is distance divided by time, Jill actually sees the ball move faster. But what if Jack's bouncing ball is replaced with two mirrors which bounce a beam of light between them? Jack still sees the beam go up and down, and Jill still sees the light beam travel a longer distance. Except this time Jack and Jill cannot disagree on the speed, because the speed of light remains the same no matter what. And if the speed is the same, while the distance is different, this means the time taken will be different as well. Thus time must tick at different rates of people moving relative to each other. Imagine that Jack and Jill had highly accurate watches that they synchronised before Jack boarded the train. During the experiment, Jack and Jill would each see their own watch ticking normally. But if they meet up again later to compare watches, less time would have elapsed according to Jack's watch, balancing the fact that Jill saw the light move further. This idea may sound crazy, but like any good scientific theory, it can be tested. In the 1970s, scientists boarded a plane with some super accurate atomic clocks that were synchronised with some others left on the ground. After the plane had flown around the world, the clocks on board showed a different time from those left behind. Of course, at the speed of trains and planes, the effect is minuscule. But the faster you go, the more time dilates. For astronauts orbiting the Earth for 800 days, it starts to add up. But what affects humans also affects machines. Satellites of the Global Positioning System are also hurtling around the Earth at thousands of miles an hour, so time dilation kicks in here too. In fact, their speed causes the atomic clocks on board to disagree with clocks on the ground by 7 millionths of a second daily. Left uncorrected, this would cause GPS to lose accuracy by a few kilometres each day. So what does all this have to do with time travel to the far distant future? Well, the faster you go, the greater the effect of time dilation. If you could travel really close to the speed of light, say 99.9999%, on a round trip through space for what seemed to you like 10 years, you'd actually return to Earth around the year 9000. Who knows what you'd see when you returned? Humanity merged with machines, extinct due to climate change or asteroid impact, or inhabiting a permanent colony on Mars? But the trouble is that getting heavy things like people, not to mention spaceships, up to such speeds requires unimaginable amounts of energy. It already takes enormous particle accelerators, like the Large Hadron Collider, to accelerate tiny subatomic particles to close to light speed. But one day, if we can develop the tools to accelerate ourselves to similar speeds, then we may regularly send time travellers into the future, bringing with them tales